Um, Today's lesson, section 6.3c, trigonometric functions of angles, we'll be discussing inverse functions. Now for sine, cosine, and tangent, we will be restricting the domain and range. Now if you think about the unit circle, and let's take sine, if you think about, let's say, where sine is 1/2, you would look at your unit circle and say 30 degrees and 150 degrees. So because they double up on answers, we want to restrict the domain in a way that gives us just one answer, or covers all the answers, but you only get one value, so that it actually passes like a function sense of the word. Okay, so for sine inverse, remember a sine is attached to your y, so these are discussing, this domain is discussing your y values. I know that's different, but then so it'll be talking about the y. For the cosine, the domain is still the x. I know that the y is different, but because sine only talks about your y values, it doesn't have anything to do with your x's. That's why you're just you're thinking more so what you plugged into the function to get that out. And remember, it's like the opposite when you're talking about inverses. Okay, so for sine, let's just talk about that real quick. So you're going from -1, so down here, this point, so 0, -1, that's the lowest sine can be, to the top, where that's the highest value that sine can be for a y value. So now that restriction, you're only going to go from -90 all the way around. So sine covers the first and the fourth quadrants. Okay, so it's in this quadrant and that quadrant. Okay, so that range gives you all the values from -90 to 90, which on your points give you all the values for a y that you could possibly get on the unit circle without doubling up. Okay, now that also includes your pi/2 and your -pi/2, because you want to be able to say that you can get 1 and -1. Okay, so that's why we have brackets there. Okay, all those are in interval notation. Cosine is for your x values. It doesn't have anything to do with your y, so that's why it's just for x. And it goes from -1 to 1 as well, but it's on the x-axis, okay, because it deals with x. So it can go from the first quadrant and the second quadrant. Okay, so you can get all those values for cosine just like you can for sine, but yet your range of like radian measurements or degree measurements are going to be from 0 to pi or 180. Okay. And then for tangent, now tangent's a little different. It's very similar to sine in the sense of its restrictions, but remember, tangent can be whatever it wants to be. So it'll go from -infinity, should probably use a different color, okay, from -infinity to +infinity, okay, but it's going to be restricted to the first and fourth quadrants as well. Just because you always want to kind of have the 0, the initial side to begin with. So for tangent and for sine, you can have negative angles for your stuff. Okay, it's possible to have a negative answer. Now the reason why we don't include -pi/2 and pi/2 for tangent is because if you write the y over your x for those points, you get an undefined value. You either get 1 divided by 0, which is undefined, or you get -1 divided by 0, which is undefined. Okay, so you can't do those. So sine and tangent are restricted to the first and the fourth quadrants, cosine is restricted to the first and second quadrants. That gives you all the correct values for each of those trig functions without doubling up. Okay? In class, I'm going to show you how to do inverse trig functions on your calculator. So when we get to that, I'll show you, okay? Tomorrow. Okay, so example 4 wants us to be able to find the exact value. So these ones, we'll use our unit circle. So for sine inverse of 1/2, I want to look at my unit circle and say, okay, where is 1/2 located in the first and the fourth quadrants for sine? And so I look at my y values, and it looks like it'd be 30. Okay? And that would be your answer. So here, there's not really going to be much work to show. So because you're just going to look at your unit circle and see that it's those values. Okay? It's just about being able to locate the correct value. Okay, letter B, cosine or inverse cosine of square root of 3/2. Now cosine is in the first and second, so let's go to one of those ones. Now also notice that it's positive, so you have both quadrants that are positive and negative. So first quadrant is the only place where it's positive, okay, and that's also going to be 30 degrees because that's where a positive square root of 3/2 is at for your x value. And now for tangent, you'll have to do a little bit more work here. It says the inverse tangent of -1. Okay? Now -1 is not a value that tangent can get just by looking at your x individually and your y individually. You'll have to combine the two. So you have to think, okay, it's negative, so which quadrant is going to be? Is it going to be in the quadrant 4 or quadrant 1? Because it's negative, it can't be quadrant 1 because that's all positive. So quadrant 4 must be it. So you have 3 points to look at. Now, which ones are going to divide each other evenly to give you, or cancel out evenly to give you 1, or -1? And that would be your 315. Okay? But because you go into a negative rotation, let's go back to that picture. So for sine and cosine, you always are starting at 0, so you either go up like clockwise to get to that angle in the first quadrant, or you go counterclockwise to get to the angle in the first quadrant. You'll go clockwise to go get a negative answer for the fourth quadrant. So your answer should be the negative of that. So it's not going to be in between 0 and 360 or 0 to 2 pi. Okay? So here, instead of saying 315 degrees or 7 pi over 4, you need to take that value and subtract 360 from it. And that's going to get you -45. Okay? Or negative pi over 4, whichever one. Okay? So those would be your answers for just if you wanted to find the exact value. If I want to be able to find the approximate values, this is where your calculator comes into play. So I'll show you this specifically. I can kind of tell you through this. So if I want to find inverse sine on the calculator, there are inverse sine, inverse cosine, inverse tangent above your sine, cosine, tangent buttons. If you press second to plug those in, you get the sine inverse on your calculator, but then you type in the number you want. So sine inverse sine of 0.62 would be 38.31, which we'd say 38.32 there. So then for letter B, if we want to take cosine or the inverse cosine of 3, now if you looked at your unit circle, you'll notice that, remember, the domain for x is in between -1 and 1. So because you're asking for a value that's outside that domain value, you're not able to actually take the inverse cosine of this value. So we would say that it's undefined. Okay? And then the inverse tangent of -2, Now here, because you have the domain is from negative infinity to infinity, you can find the domain of this. So you would have to click or press second the tangent button, which gives you the inverse tangent, and you plug in -2, and that would give you negative 63.43. And remember, these are answers in degrees. Okay? You're getting radian or degree answers out of these examples. Okay? So then for the last example here, we want to find the angle of theta in the triangle ABC. So here, if I want to find this angle, I need to use the correct trig function that would help me apply to this. So I have the adjacent side, plus I have the hypotenuse side of this angle. So therefore, that means I need to use cosine. And so then adjacent over hypotenuse gives me 6/15. To find the angle, I would want to use the inverse cosine. So kind of like taking both sides by the inverse. So doing that, actually, the inverse cosine of cosine is just theta. And so then you're left with inverse cosine of 6/15. You could reduce that to 2/5 if you'd like, and just put in 0.4, but you can leave it as the same thing. So hit the second button and the cosine button to get your inverse cosine on there, and then plug in 6 divided by 15 with your parenthesis, and then press enter, and you'll get the angle measurement of 66.42 degrees. Okay? Have fun.